Hi guys, myself Shaheed-ul-Islam is screening to present the video lecture session today from the channel Scorer Arena. Today we will be drifting through 10 important problems of current electricity unit 2 class 12. We will select only the probable questions suitable for NEET and JEE examinations. We are presenting here video lecture 1. We will discuss only 50 problems from each chapter through 5 video lecture and each video lecture having 10 questions. Here you will get everything great in science and art is simple to solve the problems. They are all NEET and JEE aspirant. Here willpower is human electricity. You have enough of this electricity generated in you to achieve the greatest thing in life if you will keep the current on. Stay tuned with us and please do subscribe the channel to get more videos. Hope that our effort will make you choose to enhance your potentiality. Time to move on current problems of current electricity, and first one is that is based on the drift velocity, that is the variation of drift velocity with the physical dimension of conductor or resistor. Here we know the electric current through any circuit I is equal to NEA VD. Here N is the number density, it is number density of electron, E is the electronic charge, and A is the cross sectional area. Cross sectional area. So therefore VD equal to, we can say, I by NE into A, and it can be written in this way: 1 by NE, it is one part, other part is I by A, and drift velocity also VD equal to mu E, and this mu can be replaced sigma by NE, and E is equal to V by L, where V is the potential difference across the resistor and L is the length of the resistor. As we know, sigma is equal to mu NE, it is actually conductivity of resistor, conductivity. So VD can be written as sigma by NE, one term, and other part of this equation is V by L. So here VD equal to 1 by NE, electric current by cross sectional area. Here VD is equal to sigma by NE, potential difference across the conductor by length of conductor. So from these two equations, any problem based on the drift velocity or variation of drift velocity with the physical dimension of conductor, you first keep in mind that is this problem is based on the current control or voltage control. If it is voltage control and voltage is fixed for the combinations or for the problem, then you have to use this equation. If the current is fixed, then you have to use this equation. Here the potential difference of V is applied at the ends of the copper wire. So V given in the problem. So therefore here we can say number 1, V fixed. If V is fixed, then we can say V is inversely, V drift velocity is inversely proportional to length of the conductor, and here when current is fixed, if the current is fixed, then we can say VD inversely proportional to 1 by A, and it is 1 by R square. R is the radius. So therefore we can say here the V potential difference applied at the ends of the copper wires. So therefore drift velocity on doubling the diameter, drift velocity does not change, because here VD is independent. VD is independent of cross-sectional area, VD is independent of cross-sectional area, and here VD is independent of length. So right option here is C again. Next question. A cylindrical conductor of length L and inner radius R1, outer radius R2 has the specific resistance rho. Here the inner radius of a cylinder is R1 and outer radius of a cylinder is R2. Since the cell is connected across the lateral surface of the cylinder, here the resistance R is equal to rho L by cross sectional area, but here the cross sectional area goes on increasing with the rise of the radius, as the cylinder is hollow cylinder. So therefore I have taken here a small part of the spherical circular part. This part is of the at a distance x, that is radius of this small circular ring I have taken of radius x, and thickness of this is dx. So of this thickness dx of radius x, there is in a cylinder, here we can find a cylinder, and if we take the resistance dr, this can be written as rho, and thickness of this circular ring I have taken here dx. So this is dx, and the periphery of this is twice pi x and length is L. So the area of the cylindrical sheet, this is twice pi x is the periphery, and length of this cylinder given, it is L. So this is cross sectional area of the cylindrical sheet. So this is the resistance, very small resistance of this thickness dx. And on integration, rho by twice pi L, this is dx by x, and the inner radius of the cylinder is R1 and outer radius of this cylinder is R2. So the resistance across the lateral face of the conductor R is equal to rho by twice pi L, it is ln x R1 R2, and rho by twice pi L, this is ln R2 by R1. And electric current, find the current drawn from the cell. Electric current I is equal to EMF E by resistance. So from here we can say the answer is A. Next question. Three unequal resistances connected in parallel are equivalent to a single resistance of 1 ohm. If the two resistances are in the ratio 1:2 and no resistance is fractional. So let us say resistance is X and resistance on other two having the ratio 1:2. So therefore we can write here, if one is Y, then the other is 2Y. So 3 resistance X, Y and 2Y. And the equivalent of this is 1 by R, and as per the questions it is equivalent of this 3 resistance is 1. So we can say 1 by X, it is 2Y, 2 plus 1 and it is 1. So 1 by X is equal to 1 minus 3 by 2Y. Here important information, if no resistance is fractional, so the value of X, Y and 2Y, this is not fractional, so therefore by error and trial method we can say the value of X, if I take it, if it is 1, so therefore 1 minus 3 by 2I is equal to 1, and here minus 3 by 2y, 1 minus 1, it is equal to 0. So y become infinity, so this is not possible. Similarly, by error and trial method, if we consider the value of X is 2, then 1 by 2 is equal to 1 minus 3 by 2y, then 3 by 2y is equal to, becomes half, so therefore y is equal to 3. But here you have to find out the largest of the 3 resistance. If we take X is equal to 2 ohm, then Y, the value of Y is 3 ohm, and other resistance, it is in the ratio 1:2. So if the one resistance is Y, then other resistance is 2Y. So largest resistance you have to find. Here you have to find the largest resistance. The largest of 3 resistances. So I think X is equal to 2 ohm, Y is equal to 3 ohm and 2Y is equal to 6 ohm, and the equivalent of all these 3 is 1 and no one is fractional, so therefore the answer is 2. So next interesting questions of this chapter, a battery of 10 volt is connected to a resistance of 20 ohm through a variable resistance R. The amount of charge which passed in the circuit in 4 minutes, we know the electric current is equal to dq by dt, rate of flow of positive charge. So therefore dq by dt is equal to, we can say, V by R. V is the potential difference and R is the resistance of the conductor. Initially the resistance is 20 ohm through a variable resistance R. So this resistance is variable. If the variable resistance R is increased at the rate of 5 ohm per minute, so resistance of the conductor R starting from 20 ohm, and finally after 4 minutes the resistance become 40 ohm. Initially the resistance is 20 ohm and finally the resistance of this conductor 20 plus 5 ohm per minute, and the time given here is 4 minutes, so therefore it is 4, and finally the resistance of this conductor becomes 40 ohm. So this is the problem based on the variable resistance. As we already solved the question number 2, that also based on the variable resistance. So we need the equation having the variation of resistance. We can say this is dq by dr and it is dr by dt, and dr by dt is given in the problem, and this is v by r. So dq by dr is 5 ohm, that is the per minute, 5 ohm, and minute, that is 60 second, and this can be written as v, that is 10 by r. So simply dq is equal to 120 on simple calculation dr by r. So very small charge passing through conductor of resistance, this is the change in charge and this is the change in resistance, since this resistance is variable resistance. So on integration, q is equal to 120 integration dr by r. Lower limit is 20 ohm and upper limit of this problem is 40 ohm. So 120 ln r integration over 40 ohm, 20 ohm. So simple calculation, it is ln 2 coulomb. So our answer here is B. Next problem. In the given circuit, R1 10 ohm, R2 6 ohm, and potential difference 10 volt. Here in a circuit, 2 ammeter given here. Here ammeter is A1, that will measure the circuit current, and A2 is the ammeter that will measure the A2 is the A1 that will measure the circuit current, and A2 is the ammeter that will measure the current through this branch. Okay. R1, 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 all the resistance are equal. You know, R2, R2, these two branches are connected by the resistance R2, 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 and here also an ammeter A3. All this ammeter given here as ideal ammeter because there is no information given on the resistance of the ammeter. So therefore, you don't take the resistance of the ammeter because ammeter just ideal ammeter though, so therefore we can say the resistance of the ammeter is negligible. It just measured the circuit current or the current through the branches, and these two branches are connected by the R2, 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 that is the value of 6 ohm. You know, the potential difference across this cell is 10 volt. If we consider that taking the reference potential here, it is 0 volt. Normally, it is the best way to take the reference potential is 0 volt. Then other plate we can say 10 volt. So potential of this point is 10 volt and potential of this point is 0 volt. If we take the reference potential is 0 volt. So potential of this plate is 0 volt and potential of the other plate is 10 volt. Since this point is connected, the node are connected by a simple wire. Node of the connected is connected by a simple wire. So no potential drop in this branch. Potential of this point is 0 volt and potential of this point is 0 volt. Potential difference across this is 10 volt. Potential difference across this is also 10 volt. Since these two resistance are equal, potential drop here and potential drop here, potential drop here and potential drop here, equal potential drop, and the potential of this point is 10 volt. So what is, I don't know what is the potential drop here, but potential drop in this resistance R1 and in this resistance R1 are equal. So potential of this point and potential of this point, potential of this point and potential of this point also are equal, because drop in this part, drop the upper part and lower part, since drop are equal, potential of this point, that is node potential and node potential here, these two potential are equal. Similarly, potential at this point and potential at this point, same resistance, equal resistance. So potential drop here and potential drop here are equal. So node potential here and node potential here also are equal. And by the similarly, we can say the potential of this point and potential of this point are equal. Therefore, no current pass through the branches R1, R2, R2, R2. No current pass. This circuit can be simplified. Not necessary, but for our better understanding, you know, it is R1, 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 and it is R1, 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 and connected by this is 10 volt. Current passing through this I and current passing through this is also I, and total current I have taken here is 2I. Resistance, same current passing through all the resistance, same current passing through all the resistance. Since the resistance, current passing through all the resistance are same, we can say R1 plus R2 plus R1 plus R1 plus R1. These four resistance are in series. So the total resistance in this branch is 40 ohm. 40 ohm. And potential difference across this is 10 volt. So current through the branch where ammeter, since you have to find out the reading of the ammeter 2, ammeter 2 is connected in this branch, that is upper branch. So current through this branch, you know, potential difference V across this combination V, and the resistance, equivalent resistance of this branch is 4R1, and potential given is 10 volt, and potential resistance of this branch is 40 ohm. So the current through this branch is 1 by 4 ampere. This means the ammeter in this branch measure the current 1 by 4 ampere, that is the right option C. Next problem. Maximum power developed across the variable resistance are in the circuit in figure is. This circuit can be redrawn. Here the cell is 10 volt and the internal, the resistance are 1 ohm, resistance 1 ohm is connected in the branch of the cell, This resistance and this resistance can be considered as an internal resistance, because if it is outside the cell or inside the cell, doesn't matter what is the current or what is the power developed or voltage drop, that will be equal if this resistance here or in the resistance inside the cell. So therefore the circuit can be redrawn here this is 10 volt internal resistance 1 ohm, 10 volt internal resistance 1 ohm, and external resistance is R. But the question is asked maximum power developed across the variable resistance R. So this resistance is variable. But in a particular, for the particular value of external resistance R, the power developed across this is maximum. Here, important funda of this type of problem, for this type of problem, important funda, current through external resistance is maximum when equivalent external resistance is equal to equivalent internal resistance. So this is important fundamental for this type of problem. If the current is maximum through the resistance R, so we can say the power developed across it is also maximum. Here, equivalent of these two internal, since it is connected, parallelly connected. So therefore, the equivalent internal resistance is equal to, it is half ohm, equivalent internal resistance, and external resistance is R. And the maximum current through this circuit, that is through external resistance, EMF E, external resistance plus equivalent internal resistance, equivalent external resistance plus equivalent internal resistance. Two cell, 10 volt 1 ohm, 10 volt 1 ohm, so identical cell. This is the combination of two identical cell connected in parallel combinations. So effective EMF is 10 volt, and here is single external resistance here. So this is not necessary to find out the equivalent external resistance. So simply it is R, and equivalent internal, it is RE. Therefore this is 10. Important fundamental, current through external resistance is maximum when equivalent external resistance equal to equivalent internal resistance. So R, if this R is equal to equivalent internal resistance, we can say the value of external resistance is half and equivalent internal resistance is equal to half. So the maximum current through this circuit is 10 ampere. Simple power across this, maximum power across this. Maximum power, it is I square R, since the current through the external resistance already calculated in this problem, maximum current through this resistance. So the formula you have to use, power maximum is equal to I square R. And this is 10 ampere whole square, and resistance external half. So this is 50 watt. So right option here is A. A torch bulb rated 4.5 watt, 1.5 volt connected as shown in the figure. This is an electric bulb of 4.5 watt having the potential difference across it is 1.5 volt. So current through this branch, you know, power, voltage into current, that is potential difference across the appliances, and current through this. It is also the definition of power. This is actually definition of power. And current through this branch, that is through the appliances, is I1. So this can be written as P by V, and power, you know, 4.5, and potential difference across 1.5. So this is 3 ampere. And potential difference across this is 1.5 volt. Since lamp and this resistance connected parallelly through the common point, so potential difference through 1 ohm is also 1.5 volt. So current through this branch is I2. This can be written as I2 V by R, and potential 1.5 and resistance 1 ohm. So current through this branch is 1.5 ampere. So total circuit current is equal to I1 plus I2. So 3 plus 1.5, 4.5 ampere. The question is asked here, EMF of the cell needed to make the bulb glow at full intensity. This bulb will glow at full intensity when the potential difference across it is 1.5 volt. Because it was rated here 4.5 watt and 1.5 volt. But the question is EMF of the cell, we know potential difference across external resistance plus lost volt. EMF of the cell is all time is equal to potential difference across external resistance plus lost volt. Lost volt is the potential drop inside the cell. Potential difference across the cell is 1.5. And internal drop, we can say circuit current is I, that will pass through the cell, and internal resistance given, it is small r. I have taken here small r. So 1.5, total circuit current is 4.5, and internal resistance 2.67 ohm. So 1.5 and 4.5 roughly multiplied by 2 or 2.5, so it should be the greater than 9. Without calculation in the examination hall, try to find out the answer without calculation. Just by applying logic, you know, if we take 4.5 and it is 2, then it is 9. But 4.5 multiplied by 2.67, so the result is also multiplication of this should be greater than 9. 9 plus 1.5, 9 plus minimum value of this is I have taken here, if it is 9, then 9 plus 1.5, so 10.5, but there is no here, you know, potential difference across this is 4.5 volt, but the answer should be at least by taking some logical consideration. At least it is greater than 10 volt. So 4.5 volt is not the answer, B is 1.5 is not the answer, and 2.67 is also not the answer. So only one option here is 13.5 volt. So I can, by this way, I can say it is roughly 12 volt. So therefore, it is 13.5 volt. Next problem, as the switch AC is closed in the circuit shown in the figure, current pass through it. It is. When this potential of the node 20 volt, potential of the node 5 volt, and when this switch is closed, the potential of the node, I have taken here a node here, since it is grounded, the potential of the node is 0 volt. So here the one node is A, other node is B, and other node is ground, and here one node, junction of the circuit, the potential of this node is unknown to us. If we take the potential of the node is X, so this is the node of unknown potential. Potential of this node is 20 volt, potential of this node is 5 volt, potential of this node is 0 volt since it is connected to ground. Here, through the nodal method, with the help of the Kirchhoff current law, either you have to take all the current entering into this unknown potential node through all branches, or you have to take all the current leaving the node. The potential of this node, since it is unknown, so we can't say definitely current entering, or current leaving. In this particular case, unless the potential of this node is known to us, we can't say through which branch the current is flowing. Current is entering or leaving in this branch, in this node. Here, I am considering here current through all branches entering into the unknown node. Either you have to take all the current entering into the node or leaving from the node. But you don't take one current is entering, other current is leaving. In this way, since the direction of current is not confirmed because the potential of this node is unknown, so here important two consideration. Either you have to take all the current entering or you have to take all the current leaving the unknown potential node. But one confirmation by the KCL, Kirchhoff current law, we can say you have to apply the current law at the unknown potential load. The algebraic sum of current I1 plus I2 plus I3 equal to 0. So this is the confirmation was given by Kirchhoff. Here I have taken all the current entering into the junction. If you think that you can take also all the current leaving the junctions, but don't take one entering, other leaving. This one is leaving, this one is entering, this one is leaving, this one is entering. Don't take in this way because the potential is unknown. So here, all the current entering into the unknown node, and now by the simple conception of the Ohm's law, potential difference current through this branch 20 minus x by 2 ohm, and current through this branch 5 minus x by 4, and current through this branch, node potential of this is 0 volt because it is grounded, so 0 minus x by 2, and it is equal to 0. Simple calculation, 40 minus 2x plus 5 minus x minus 2x equal to 0. 5x is equal to 45, then x is equal to 9 volt. So potential of this unknown potential of the node, that is the potential of the node is taken x, and the potential of this by the solving of this problem, x is equal to 9 volt. So potential of this is 9 volt. Question is asked, what is the current through this branch? So I3 is equal to, 0 minus x by 2, so it is minus 9 by 2 is equal to minus 4.5 ampere. I have taken here the current entering, but algebraically the minus current entering, negative current entering, algebraically it means current leaving through this branch. So the direction of current actually it is I3. So this is not the direction of current. The actual direction of current is from this node to ground. So I3, the value of I3 is 4.5 ampere. Next problem. In the circuit shown current through 25 volt cell, this problem can be solved by KCL or KVL, but my recommendation, don't apply the KVL to solve this problem in the examination hall, because through the KVL it will take longer time to solve the problem. So for quick response, this problem also can be considered as a painless problem. Here my suggestions, you go through the reference potential taken. Better to take here the reference potential. Always it is highly recommended the reference potential should be 0 volt. You can take the reference potential any value, but my recommendation, strongly recommendation, you all time take the reference potential any problem or any circuit. If it is required, then you take only 0 volt as the reference potential. If we take the potential of this plate is 0 volt, so potential of this plate is 25 volt because the potential difference is 25 volt. So if it is 0 volt, I have taken as a reference, so potential of this node is 0 volt and potential of this node is 0 volt, potential of this node is 0, 0, 0. Potential of this node 25 volt, potential 25, potential 25, 25, 25. So all the nodes having the same potential, since it is connected by a wire having the negligible resistance, and potential of the lower branch, all the nodes, it is also 0, 0, 0. Here the potential of this plate is 25 volt and potential of the lower plate should be 15 volt because potential difference is 10 volt. Potential of the plate 25, then higher potential plate should have the potential is 30 volt क्योंकि the potential difference between these two plates is 5 volt given in the problem. Potential of this plate, if it is 25, then the potential of this plate is 5 volt. Potential difference is 20 volt. Potential of the plate is 25, then the potential of the plate having higher potential, it should be 55, because potential difference is 30 volts. 55 minus 25 is 30 volt. So taking the reference potential 0, I have calibrated all the node potential here. Simple. Potential across this resistance 15 volt and 0 volt. So current through this branch, let us say I1, then I1 from the Ohm's law. Simple. Potential difference of the across the conductor by resistance. Potential difference is 15 minus 0 by 5. So this is 3 ampere. Current through this branch, let us say I2, then I2 is equal to 30 minus 0 by 10 is equal to 3 ampere. Current through this branch I3, then I3 is equal to 5 minus 0 by 5, so it is 1 ampere. Current through this branch is, let us say I4, then I4 is the potential difference 55 minus 0 by 11 is equal to 5 ampere, and all this current I1, I2, I3, I4 that will pass through the cell 25 volt potential difference. So current through the 25 volt cell is I1 plus I2 plus I3 plus I4, and this value is 3 plus 3 plus 1 plus 5. So the total current through this cell is 12 ampere. So our right option is C. So in this way, taking the reference potential 0 volt, you can find the potential of all nodes here. Those are connected by the simple wire. And keeping the potential difference same, you have to put the potential of the plate of two electrodes of the cell, that is 15 volt, 25 volt. In this way, you just write the potential of the all plates of the cell, and by simple calculation or without calculation, the current through this branch, current through this branch, current through this branch, by taking the Ohm's law, we can find the current without pain also. And total current, go through this cell, so therefore the total current is 12 ampere. So this problem can be solved without paint also. This is painless problem. If you think that the problem will be solved without pain, but today here I am calculating, because for your better understanding, though you can find out, you can understand the problem properly. So therefore I have here, therefore I solved this problem. I have solved this problem by taking the simple calculation, but without pain you can solve this problem. Next problem of this chapter: if potential difference between B and A is 4 volt in this given figure, then resistance X will be, if we take the current, potential of this 5 volt and potential of this is 2 volt, then we can say current delivered by the higher potential in the circuit, current pass in this direction, because the potential of this cell is 5 volt and potential of this cell is 2 volt. These are connected in opposite polarities, but the current through this branch is provided by this cell. Okay, so current in this circuit I is equal to, since these two cells are connected in opposite polarity, we can say 5 minus 2 by total resistance, because the current passing through all resistance are same. Since the current is same for all resistance, so this resistance and this resistance are in series combination. So the circuit resistance is 10 plus x, and this is 3 by 10 plus x. So this is the circuit current. One important information given in this problem: potential difference between the point B and A. This is the point B and this is the point A. If we apply here Kirchhoff voltage law, Kirchhoff voltage law can be applied in any open circuit also, from one point to another point of the circuit. You don't think that the Kirchhoff voltage law only applied only in the case of loop or mesh. You can apply the KVL from any point of the circuit to any other point of the circuit. So starting from the point B, KVL, VB, the potential of the point, let us say VB, from B to A. If we proceed from B to A, in this branch, here the cell of potential difference 5 volt, but from B to A, if we go through this way, then first we get the positive plate, then negative plate. So internally from positive plate to negative plate, internally from positive plate to negative plate, this means potential drop, that is minus. Another element, resistance of 10 ohm, since against the direction of current, we are traveling against the direction of current, through the resistance. It is actually potential gain, and it is equal to the potential of point A. So from any point to any other point of the circuit, we can apply the Kirchhoff voltage law. You know, VB minus VA, and this is minus 5 10 into I equal to 0, and VB minus VA, that is potential difference between 2 point VB, B and A. It is given in the problem is 4 volt, it is minus 5, and this is 10 I equal to 0. So current I is equal to 1 by 10 ampere. So circuit current here is 1 by 10 ampere just by applying KVL. And equating 3 by 10 plus x is equal to 1 by 10. So 10 plus x is equal to 30, and X is equal to 20 ohm. So here right option is D. And this problem also can be solved. This problem also can be solved if we think that, if we consider the 10 ohm as the internal resistance of this cell and X is the internal resistance of this cell. So these two cells can be connected and or redrawn. It is 5 volt 10 ohm, internal resistance 10 ohm, and it is point A, point B, and the potential of this is 2 volt, and X, the resistance, is taken as the internal resistance, and the potential between these 2 points is given in the problem is 4 volt. So if we calculate, this is the combination, this is the combination of non-identical cell. In the case of non-identical cell, effective EMF E is equal to E1 by R1 plus E2 by R2 by 1 by R1 plus 1 by R2. So putting the value in this problem, E, that is the potential difference between B and A, is given is 4 volt. E1 is equal to 5 by 10 and E2 is equal to 2. Internal resistance is 1 by X, and this can be written as 1 by 10 plus 1 by X. So 4 is equal to 5x plus 20 by x plus 10, 40 plus 4x is equal to 5x plus 20. So therefore X is equal to 20 ohm. So in the another way, alternative method, if we consider the 10 ohm as an internal resistance of this cell, since this resistance is connected in the branch of the cell and X is also connected in the branch of the cell, so X can be considered as the internal resistance of the cell, and 10 can be considered also the internal resistance of the cell. And this is the combination of non-identical cell. When the cells are non-identical, the effective EMF between the ends of the common point, you can all time you can say E1 by R1 plus E2 by R2, 1 by R1 plus 1 by R2. So by applying this formula, it is effective in the competitive exam. For the competitive type of exams, you can apply this formula directly by taking the resistance, internal resistance, taking the resistance in the branches of cell as an internal resistance, then applying by this formula, you can find out X is equal to 20 ohm. So that's all for today.